Good evening, everybody. So let us start our lecture tonight. And today is March 16th, right? And then according to our schedule, and then actually we completed recursion. Before we went to break, we completed recursion, right? So in our last lecture, we completed this module 5. Okay, so has anyone any question about module 5 recursion? And I asked you to practice some programs from the recursion module. And actually I discussed in the previous lecture. And then let me see that which slides. What lectures I uploaded last time. Okay, introduction to recursive recursive call. After that, there is another lecture. So today's lecture will be lecture 14, 15, 16, 17. There was a test. So today's lecture will be 17. 15 lecture I will upload that, and 16 was the test. One of those was test. Oh no, 12 was the test. So today's lecture will be 16. I will upload it. Okay. Okay. So. So as we've completed recursion in our previous lecture, has anyone any question about recursion? Okay, so if you have a question about recursion, okay, then please bring it up in our next time. I will discuss. I will review. So recursive method and recursion process is very important for many purposes in data structure, algorithm. Okay, and for many purposes you will see the recursive process. So you should have clear understanding about recursive process. Okay, there is no way that you can skip this. So in your test, in your upcoming test, you will get at least 2 questions from recursion. Okay. So like today we will discuss module 6, exception handling. So in this week, if we can cover module 6, exception and error handling, then maybe next week we can do file IO operations, and then we can do another, we can move up one lecture to week 10 from week to week 11 from week 12. My goal is to discuss 2 lectures for thread and multi-thread programming and parallel programming. Okay, so the one day will be test, right? So on the test day we will miss a lecture, so that there is only one lecture, but I want to assign one lecture here. So today we will discuss exception handling. Okay, so in English, in natural English, what is an exception? What is an exception? Yes, tell me. Yes. You should know. You are an native English speaker. Okay, I believe. Okay, what is mean by exception? What do we mean by exception? Anyone can help me?
Something outside the norm.
Yeah, something else than normal, right? Like an accident. An accident may happen anytime. I was asking without any context of programming. In natural English, native English language. So an exception means something unusual, right? It's not normal, something abnormal, something that happens suddenly without giving any notice, any prior notice, right? So maybe like an accident. It can happen anytime, right? Okay. But there are some ways to avoid exceptions or like accident, but we cannot ensure that, we cannot give guarantee that we will not have an accident, right? Whenever you are driving, you are good, you are a good driver, you are driving good, nicely, but the other side, the other person may drive wrongly, right? So you may fall an accident. So due to maybe even not you, by your fault, you can get an exception or like an accident by some other people's mistake. Okay, same thing in programming languages. It happens, exception happens, some unusual activities happens, or it may happen. So it's a normal thing that no programmer can claim that I am a perfect programmer, I never do a mistake. Everybody does mistake as a human being, right? No matter how skilled programmer a person is, everybody does mistake. And then what a wise person does, a wise person learns something, get some lesson from a mistake, right? Whenever we do some mistake, we should get some lesson so that we do not do same kind of mistake again and again. You can avoid, right? Okay. So like in programming, there are exceptions, that mean unusual activities. It happen or may happen. So our goal is to avoid those exceptions or unusual activities. So what does exception can do? An exception that can terminate our program. If it is a major exception, it can restart our computer. Okay, like if your program handles operating system, it may restart your computer. But in this lecture or in this course, we are not handling operating system. We are not writing any program that will handle operating system. So at best, it may crash our IDE. Okay. So what is way? There's multiple ways. There are actually two ways to handle exception. One is to catch the exception. Whenever an exception happens, detect the exception and handle it. Okay. And then bypass the exception creation statements or something. There is another way that whenever an exception happens, throw the exception. We throw that exception, that means we bypass the exception. So there are two processes mainly, catch and then throw. We will discuss this. And at the end, then we will see that there is another way that to create our own exception. Maybe the last thing, this one I will not discuss tonight. Next lecture we will discuss how to create our own exceptions. Okay. So as I said, due to an exception, your program may crash, your application may crash, or software may be crashed. So we need to develop an application or a program that is it's called fault tolerant. That means if a fault is happened, your program is tolerable, can tolerate the fault. Okay. And we will know how do we do that. Okay, some will come in that. So like in this program, this is a good program, right? This is a very tiny program. What does this program do? It takes it has integer number 1, number 2, and result, and then it takes, this is a Java program. It takes number 1 using keyboard, and it takes number 2, and result is number 1 divided by number 2. right? So apparently this program is good. Apparently there is nothing wrong in this program. If you do a superficial look, that what does this program do? It takes two numbers and divide the first number by the second number and give you the result, right? So, but this program, while running this program may create an exception. Do you have an idea what kind of exception or problem it may create? I said it may. There is no guarantee that it will do. But by looking this code, especially the last line, do you think that anything can happen? Some unusual activities here?
A divide by zero exception?
Yeah, it may happen that you may enter the second number as 0, right? So, what may happen? If a number is divided by 0, then you don't know the result, right? Usually it says that infinity, something divided by 0 is infinity, but you don't have any specific value for the infinity. So it will give an exception. It may give an exception. It will give an exception in that situation. Okay. So in our program, how can we avoid this? Okay, there are multiple things you can do. You can ensure that you never enter 0 for the second number. Denominator, here the number 2 never be 0. Okay, so you can use a for loop, or if condition. If the number 2 is 0, then re-enter it. There may be a solution, right? One another way that if it is 0, then since it will create an exception, you can give an error message or exception message. You can print something, oh, your denominator is 0, you cannot have 0 denominator, so re-enter it or something, doing something, right? Okay, or what we can do in exception handling process, we can, the statement that may create an exception, we actually in programming, what we do, we put that statements, okay, problematic code within try block. And then try block is followed by a catch block. So catch block, what does it do? It will show you an error message, or it will do something else to avoid that exception. If someone is okay, please do not share your screen, okay? Okay. So this is a way, the main idea of using try and catch block. It's called try and catch block, and try and catch block is followed by finally block. So try block, within the try block, the code that may be potentially problematic code I put over here, and then in the catch block, if the exception happens, then the exception is resolved over here. It depends how you will resolve that exception. You can just send an error message, print message, or you can do something else. Okay. And there is also finally block that always executes. Okay, one thing before I discuss about finally. So the catch block executes only if an exception happens. If an exception, if there is no exception, then catch block does nothing. Okay, and if an exception happens, then cache block become active. Okay, but then finally block, in the finally block, no matter whether an exception happens or does not happen, the finally block codes in the finally block always execute. Okay, for some specific operation, for instance, when you open a file, and after your operation, you should close that file, especially when you do your database access database. Then database, like closing codes, the code to close the database are put in the finally block, so that at the end of your program execution, your database is closed, so that other people or other program or application can use your database. Okay. So in most programming languages, like whatever programming languages we're discussing here, two programming languages like Java and C Sharp. So like Java, C Sharp, and all modern programming languages have exception handling mechanism built in. Okay. So this is the Java programming languages compiler and interpreter. It has system. So we discussed there is top class, level class, object class, right? So it has the child class, throwable, and you see the left side error and the right sides are exceptions. So the main difference between an error and exception is that many times, in most of the time, whenever an error happens, your compiler will be able to detect it. Before you run your program, your compiler will detect when you run your program, compiler will detect the error. So if there is an error message in your program, it will not be running. So you can know that ahead of time. But it may happen that there is no issue in your program, but an issue may arise during your program, either compile time or execution time. You know there are two phases of program execution, right? Program running. First time they compile, like in Java, compiler creates source code to machine language, and then interpreter it creates machine language to discuss bytecode or what's it called in Java. Bytecode maybe. There is a good name, I forgot. Okay, so exception happen during either program compile time or execution time. So, but an error usually happen program before program compile execution time. So you can see that whenever you compile your program, you can see an error, like syntax error. If you do mistake in writing a syntax, then you see. So you see that class hierarchy. So all of these are classes, built-in classes. Okay. So in the exception class, you see that there are two types of exception class: a runtime exception, and the runtime exception has illegal argument exception, index out of bound exception. So index out of bound exception is commonly arise when this one and then this one, array index out of bound exception. This exception happens if you pass the array index of an array. For instance, if you have an array size 10, and if you want to access an element with index 10, it will create array out of bound exception, right? So we know that array index start with 0 to size -1, so 0 to 9, right? So there is no, for an array of size 10, there is no 10th index with 10. So in that case, this exception will happen. And then file not found exception. For instance, you want to access a file, the file does not exist, or the file is being used by another application or program. Okay, and that time file not found exception happens. And then another one is a socket exception. So for network programming, whenever you want to connect one computer with another computer, okay, another computer may be busy, okay, what that may not be available, or that may not be, maybe power off or out of internet or network connection. In that case, socket exception happens. Okay. Whenever you take a networking course, then you will learn how to create right program for socket exception. I may have some programs I can give you if you need it. Okay, so this is for Java class hierarchy, and they're in C#. They're pretty similar but different class hierarchy. But you see that almost there are same kind of exception, like index out of bound range exception, and then file not found exception, and this one non-reference exception and something. Okay. So let us see. Okay, so whenever we handle our exception, we will use some of these existing exception classes. Okay, and sometimes it may not be sufficient with these existing classes, so we may need to create our own exception. And later we will see that how do we create our own exception with the help of these existing classes. Okay. So the easiest way, the most common way to handle an exception is that using a try catch block. So what happens whenever an exception is happen or thrown, the program controls immediately transfer to a fast. Actually, let me show you this here. Let me try block. There is something wrong. There is something missing in this slide. So let me fix it. It should be try block over here. Try block does not take any argument. Okay, the try block. So first there is a try block. So you say try plus block. Okay, first there is a try block. So your programs, there are some codes over here, existing code. Okay, after that, if there are some codes that may create an exception, so we put that code in the try block. So then if that problem or exception happens over here, so the catch block, it takes an argument of a specific type of argument. That's a specific type of exception. So if the exception type matches with this exception, then this block will be executed. Okay. For instance, if your exception happens due to divide by 0, division by 0, then this block will be executed. Or if your exception is different kind of, for instance, array out of bound index, so then maybe your exception and another block, this block will be executed. Okay, so based on the exceptions type, we can use multiple cache blocks, but there will be only one single try block. Okay, only one try, but there will be multiple cache block, like if, else if, else if, else if, right? There are multiple things, if, else if, else if, else if. So these are the else if, else if, else if. So you see that all of these are cache. There is no cache 1, cache 2, cache 3 like this. But we say this one is first cache 1. Okay, but this is cache 2. But the keyword is cache. But we will say since there is already first cache over here, so we say cache 1. So first cache block. And then we can say this is cache 2. Cache 2 block. And so on. Okay. And we will see that it has exception type E, so this is an exception class, and this is E is an object, right? We understand this statement, right? But there is nothing new operator, but whatever it is creating a reference of exception type, and later we will use this E to call a method, built-in method that is available in the exception class. Okay. And then finally block is used to clean up your code. For instance, when you access your database, after your program execution, it closes the database. Okay. Or after you run program, it clears up your memory. Okay. Or this kind of things. Okay. So there can have multiple cache blocks, but only one try block and only one finally block. Okay. The finally block always executes, okay, no matter whether an exception happens or does not happen. So like this code snippet, you see there is a try block, there will be only one try block. You cannot have multiple try blocks, okay? So only one try block and then one or more cache blocks, and then followed by one finally block. So there cannot have any finally block without a try or cache block. Without a try cache block, you cannot have a finally block. But with a try cache, you may not have a finally block. So your program is simple. It is not accessing database. It is not using a final. You use a file. So everything you can handle in your cache block. Then we don't need a finally block. Okay. So this is a norm. How should we handle exception? Should we said that we should put the potential exception creating code in a try block. But should what we can do, we can put our entire code within a try block. But should we do that? No. Right? We should not do that. So only the potential code that has potential to create an exception, we will put those code in the try block, not all code. For instance, what happens whenever we drive a car, right? We drive outside. If there is an accident happen, we stop there, right? So there are four-way stops. There are some stops, four-way. For instance, there are four-way stops. So if there is a stop sign or a four-way stop sign, okay. So or if there is no stop sign. So in our road, when we're driving a roadside, what do we do? If there is a four-way stop or there is a stop sign, we stop for a few seconds, right? At least 1 second. We are supposed to stop at 1 second, then go. But if there is no stop sign, we may stop in case it is needed, right? So, but if we usually do not stop in every stop sign, like EL sign, for instance, like EL sign, unless there is something, another vehicle is coming. For instance, let us consider EL sign. So the EL sign, we may need to stop, right? When you're driving a car, there is EL sign, right? You may need to stop, right? But we do not need to stop if there is no vehicle coming from other side, right? So if your code does not have any chance to create an exception, we should not put that code in try block. Like if there is no accident happen, nothing, no other car is coming from opposite direction or side direction, then we should not stop in the EL sign. We should go, right? So what will happen if we stop at every EL sign, then our speed will be slower, right? So we will take a long time to reach to our destination. So same thing, okay? So it's better to stop if there is an exception happen or accident happen, that in the EL sign we should stop. Same thing, we should put our exception handling code, only the code that happens, that makes an exception in the try block, not the entire code, okay? And whenever you have multiple codes, so you can have separate try blocks, separate try and catch block based on your exceptions. Okay. So there is another way that is the first way to use try and catch block to catch an exception and handle it. Okay. So there is another way, is called throwing an exception. So throwing an exception is used inside a method. Is used inside a method. Okay. Whenever you declare a method, maybe the main method or any method, if we think that this method may create an exception, so we in the method header line I will show you code, okay, and then within the method, like we use this statement, what is a throw new exception. That is that this kind of exception is coming, then we create an object, and then of this you see that there's creating an object on the fly. We are not giving an exception name over here, object name over here. Just whatever exception is coming, just throw it out. Okay. So, but please note that for language to language, exception handling codes vary from language to language. So in this course, we are discussing two languages, Java and C#. You will see that there is slightly variation in exception handling mechanism and in class names, as we discussed here. So this is class hierarchy for exception hierarchy for Java, and this is for C#. They are not exactly same, but maybe similar. Okay, so exception handling mechanism depends and varies programming language to language. You see the top level is object, and in C# O is in lowercase, but in Java top level is object and O is in uppercase. So the second level is throwable subclass, and it is exception class. So there is a variation, okay? Okay. So here, this is code. For instance, in class, simple code. This is a method. Is this method, within this method, it is creating throw exception. So and then within this exception, it is giving this like and a message, like print message, text. Okay. And then how do we use this, call this method? So whenever we see that we call this method, so whenever this method creates an exception, so then this method is by default is creating an exception and giving only one code. So then I'm sorry. So here what happens when an exception happens? So if an exception happens in this line, then the next or following lines will not be executed. So this exception, if the exception happens over here, right? How do I know that the exception will happen? The code, it gives us that it will create an exception. It is by default creating an exception. So whenever it creates an exception, then the next line will not be executed. So you will never see this line. I'm sorry. Okay. And then you see that here, class, and then if since this exception happens over here, then class block will be activated, and then it will print whatever is the exception type E. This is an object, any name you can give it here. And then what is doing over here? It is just writing an error message with E dot message. That whatever the exception happens, what is the reason or type of the exception, it will give a message, that kind of message over here. And since, as I discussed earlier, that no matter whether an exception happens or does not happen, the finally block always be executed. So this output, we will get always this output, no matter. Okay, so now let us run this program, and then I think you will understand it. Okay. Program C#. Okay, so this is my class example. Okay, and this class has let me see the problem. Sit me to main class. Okay, so this is my program. Okay, so main class, and it has a do stop method that has an exception creation code over here. So when you call this method over here, do stop, and then this line obviously it creates an exception. Then what we'll do, whenever it comes this exception, then it will go to it will not be executing this statement. But since the exception happens here, so it will activate the catch block and it will give exception message over here. Okay, and then finally this block will be executed. So let me run this program and then I will explain it. Okay. Okay, so what is the exception? You see that exception E and say E dot message. E dot message. So what is the message is coming here? What is the output is coming over here? Whatever I write over here. This one. So if I change this one, if I run this program, then this output will come over here. You see that? CSE1322 exception. This one. Okay, this is 22 course, right? 22. So now you see that this line does not execute, right? But how about if there is no exception over here? Like it does something simple. For instance, if my code over here, okay, let's just something. This code is just it prints something in the console, right? There is no exceptional code over here, right? So then that means, what do you think, that this line will be executed or not? So after at this point, I'm asking you, so I changed this method, do stops. Okay, I gave this, instead of this previous statement, I gave this statement. So now if I run this program, let me do something, maybe you'll understand better. Okay, same thing, same output. Okay. So now at this point, what do you think? Will this line be executed or not?
Yes.
It will be executed, right? Because so there is nothing exception happened, right? So also this is the line never prints, but it is printing over here, right? It is printing here. What is the reason that this line is printing? Even although I wrote that the line will never print, because there is no exception happened here, right? Okay, but if no exception happens, and then at this point this line will not be executed. Do you see any effect of this line? Do you see any print of this line? No, right? Because you see that vice versa. If this try block executes like this code in the try block after the exception handling code, exception creation code. If this line execute, this will not be executed. Okay, but if an exception happens here, then this will not be executed, but this will be executed. So what I'm trying to tell you that, so if I give this code, okay, will my result, will my output be same? No, you see that at this point, so this will go here. This message will go, here. And then this line will not be executed, but this line will be executed. Okay, and let us see our output. So this line, this is the first line will be executed. Okay, and after this, what will come here? So after printing exception thrown here like this, it will come, the message part will come over here. So exception is a built-in class. Okay, you see that this, we are in the cast method, we are using an object of this kind. So whatever you give this object, no matter. Okay, you can create its name ex, then you can give ex, and it will give you same result. Okay, so whatever you say, if you give xxx, then how about here you will say xxx, then your program is done. Okay, and then you see that finally block, it will execute no matter whether an exception happens or does not happen. So if I execute this statement instead of the exception statement, then still this statement will be executed. If we run this program, we'll see that still it will be executed. And even I do not have that, I create an exception, then this line will not be executed, this line will be executed with this message followed by this. So this statement will be executed always. Okay. Now, can I get rid of finally block? So from our discussion, what did I discuss so far? What did you remember? Let me try. What do you think, that the program will run or do not run?
You have to have the finally block, don't you, if you have the try?
Okay. So you said that I have to have finally block? I don't think so. Finally block is an optional block. Okay. You may not have a finally block. If you think that your program is a simple program, especially the finally block, what do? We clear up memory, we close database connection, we close network connection, okay, in the finally block. But if there is no try and catch block, then sorry, I spilled my coffee cup. Okay. So if there is no try and catch block, you cannot have any finally block. So without try and catch block, we cannot have any finally block. So we cannot have any. So we have never tried. I wonder we should not have. So there is no finally block. Okay, so then, but if we try like this way, if there is a try block and then there is no catch block, it should be. Okay. How about in Java? Let me try this in Java. Okay. Okay. So I think final block always it follows a catch block. Try catch. Okay. So you cannot have a catch without try. You cannot have a finally without try catch. Okay. So now let us see. Let us see this code. Java. Okay, it is different in Java. Misplaced constructor. I will fix this code, okay? But I have some code in Java, exception handling code in Java. I'll get that. I'm running an Eclipse. Okay, I have exception handling code over here. now. Okay. So this is a Java program that handle exception. So here in my code, so similar code, okay, previous program that I discussed at the beginning. So here, for instance, we have some variables x, y, and z. So we have x equal to 5 and y equal to 10 and z equal to 15. So if we do our d1 equal to g divided by x minus 2x, that x y minus 2x, y is 10 and then x is 5, so y minus 2x, it will create an exception over here, right? It will create an exception over here, right? Divide by 0 exception. Then this statement will not be executed, right? So then what will happen? So okay, so this, so you see that the try block and then it has catch block. But this program is also that we will discuss on the, within a try block you can have another try catch block. Okay. For instance, for now, let us forget about this. So let us make it simple. So now, if we run this, okay, and one thing is that between try and catch block, you cannot have any extra code. You cannot have any other statement between try and catch block, like if and else. You cannot have any code in between. Okay, and then if you have any finally block, you cannot have finally block over here. You must have finally block just followed by the catch block. So if I have a finally block over here, so then the finally block will come over here. System dot out. Okay, so that if this block will be executed, this finally block, it will always be executed. Okay, so here the finally block, but you cannot have this code. You cannot have this code here. You cannot have this code here. So before the finally block, so between catch, try, and like catch and finally, you cannot have any other code. Okay. So then what we are discussing over here, so then we are discussing that within a finally block, within a try catch block, that can have multiple try catch block. Like this is the inner try catch block. Okay, this program will run. So there is another exception in over here, right? So it's a z y divided by z minus 3x. So g is 15 and 3x is 15. So this will, there will be another exception over here. And then if this exception happens, then it will execute this statement. So this is why output is like this. Okay. So if an exception happens, then what you can do? You can catch that exception, okay, then you can continue running your program from the remaining statements, or you can do something else. For instance, here I'm doing something else. I'm changing my d value. So instead of z, so it created. So when I said g divided by y minus 2x, it created an exception. So I said g let's set p1 over here now. So now G1 G equal to, so that is okay, right? There is no exception will happen here. So that our goal is to catch the exception, and if an exception happens, then whatever we want to do, we can send an error message, the warning message, or we can redirect, or we can change our code that created exception earlier. Okay, so then we will avoid exception. So if you go for an interview, for the job interview, then you will see that you will get a test question, interview question about exception handling. Okay, so my Java code over here. Okay. So I can change the name. I understand what is the previous program. So let me fix it. I wanted to do this. Last name. System. Using office. What is that? Still. Do you have double name? Why do you have a message like that? I copy that paste code. Oh, okay. Oh. There's some hidden text over here. Still there is an error here. I don't know. So there is something wrong in this program. I don't see any error. I'll fix it. There is something error here. It's invisible some text. It's getting some illegal character. So 8, line number 8 here. So with different font, there is some text in different font. It's invisible. I don't see. Okay, I will fix that later.
There might be an extra bracket at the bottom.
So main, no. This one is this one. Okay, you see that there are some hidden text over here. Oh, okay. Okay, got it. Clear. Can I clear it? Okay, it is getting this one. It's running right now. Okay. So maybe I can share this code with you. Is this a chat window? Can anyone please send me text message? Text chat in the chat window. Please send me a text message. Just say hello so that I can get. Anyone please send me a text message. Okay, maybe here. Okay, got it. Okay, this one. I also discussed this one. Okay. Okay, so in our next lecture, we'll discuss the remaining parts. So mainly so we got an idea, right? In this lecture, what is an exception and how an exception happens, and if an exception happens, then how can we handle that? How can we catch that? Okay, two things you see that. One thing is that throwing an exception So if you throw an exception, then you do not need to try catch block. Okay, but if you have try catch block, then you do not need to throw an exception. There are two alternatives for you. Okay, so then two ways that we discussed. One is throwing an exception, another is try catch block, using try catch block. Okay, so throwing an exception, throws message. See, the throws is used on the header line. That means this method is the potential exception creating method, right? So if it creates an exception, then this method itself will throw that exception. So then in that case, you do not need to use try catch block. So for instance, this one. So if you say throws, then you do not need to use try catch block. Just use throws. Okay. Even in the main method, you can use throws. Then in our next example, next lecture, I will show you some example. Like I have some exception. I'm giving you this one, these links. So if you put this here, then there are some more codes over here. You will see that there are some programs here that has exceptions in the main method. Where is that one? Somewhere. I will get it in the next lecture. So then in our next lecture, mainly we'll discuss how to create our own exception. Okay. Hopefully this week we will complete this exception handling. Okay, next lecture. So has anyone any question? So in your text, in your interview question, you will get some. In the interview, you will get some questions about exception handling. Okay. Okay, there are two kinds of exception. It's called checked exception and unchecked exception. We will discuss this in our next lecture also. So this last slide. Okay. Okay. Has anyone any question? You have a question? Okay. Okay, thank you everybody, and have a good evening.